Okay, so today we're talking about classical conditioning, one form of associative learning. The focus is going to be on classical today. We'll talk about operant next, but the big differences are something that you should be looking for, right? You should recognize when something is classical conditioning versus when something is operant conditioning, as well as when something is, cognitive learning. So in these associative forms of learning, recall that we're focused on associating two events together, right? Two things that are happening together. And in classical conditioning, that's typically with some form of automatic reflex as well as some form of neutral stimulus. Helps us predict events, whereas in operant conditioning, we're associating behaviors typically more with consequences, right, with a reward or a punishment. Most forms of dog training, sleep training, or children, all of those are forms of operant conditioning. And so with these, what we're really doing is we're building habits, right? Learning is in many ways, we're talking about habits more than we are like facts and figures and things you're learning for school. These are learning our behaviors. So these are the habits that we're developing. And psychology tells us that like after 66 days is about on average, that's the kind of threshold of when something becomes habitual, as in very much a part of our behaviors. And so classical conditioning is where we associate two stimuli to anticipate events, right? But this is all a part of this classical form of behaviorism, where psychology believes the early psychologists like Skinner and Pavlov believed that they should focus on objective science and study behavior without thinking about what's going on in the brain. Today's researchers, of course, disagree. They want that biopsychosocial, but in the early Watson, Skinner, Pavlov form of behaviorism, this got popular because it was a science that they could do, right? They didn't need to read brain scans. They didn't have the technology for that yet. But behaviorists believed then that like they had hard science because they were looking at things that were observable and therefore provable. Yeah, we'll talk about a couple different examples, but like you see in this bottom right, we get a stimulus of lightning. Stimulus 2, after that we get thunder. Right? A response is that we react, right? When thunder shakes the house, we react like, we're afraid of that. But now when we see lightning, which technically doesn't shake the house and make us afraid, lightning itself is silent. But our response is that we're expecting that loud noise, right? Lightning itself is not scary, right? Unless, of course, you're out in it. It's completely silent. It's just electricity, but it's the thunder that often scares us, right? It's the sound. And so we react to that by wincing. But then eventually classical conditioning will have us react to lightning, even though lightning cannot shake the house unless it strikes the house. Lightning itself is, just light. We haven't been given any reason to be afraid of it other than the fact that it causes thunder. We are anticipating and nervous about the thunder that is to come. So terms you should know for classical conditioning. Neutral stimulus, unconditioned response, conditioned stimulus, conditioned response. I would remember these by chunking these into two halves. One, we've got the first portions are the things that happen naturally, right? And these are, if you want to remember it this way, unlearned. Okay, these are things, this is before we've had any form of training or conditioning. So a neutral stimulus is something that will not get a response from us, right? A neutral stimulus in the lightning and thunder is lightning. When we just see lightning, a flash of light, or off in the distance, we see lightning. Most of the time that's going to be like, oh, interesting. That was pretty. That was cool. But we're not going to jump back and be afraid. Naturally because of just seeing lightning off in the distance. But unconditioned stimulus is something that's always going to trigger a response, like the house shaking, right? The thunder coming down. And then the unconditioned response is that reflex. That reflex or unlearned response is a reflex when the house shakes and the thunder hits. So over time, we pair these together, the pairing of the neutral stimulus and the unconditioned stimulus, to eventually shape things into a conditioned stimulus and conditioned response. So a conditioned stimulus was originally nothing. Originally, it was the neutral stimulus. So the neutral and the conditioned stimulus are the same. Okay? The difference is the response. Okay? The difference is the response. The conditioned stimulus is lightning here. It's neutral at first. It doesn't cause us to be anxious and worry about a loud sound. But after a while, we associate lightning with thunder. And then now lightning becomes a conditioned stimulus where even if we don't hear thunder, even if we see lightning off in the distance, it makes us anxious and it makes us nervous. And we begin to maybe, like Padfoot does, whenever he sees lightning or begins to like feel rumblings or think about that, he always goes and hides back in the room because he doesn't like it. It makes him nervous. And so his response, even when he sees lightning, even if he hasn't heard thunder yet, he'll go and hide in preparation because of the anxiety that's building up. So conditioned stimulus is the neutral stimulus after it has been associated with the unconditioned stimulus. So the conditioned stimulus is the same as the neutral stimulus, but it's now a learned stimulus. It's now something that shouldn't have caused a reaction, but now it does. And now it causes the conditioned response, which is, the same as the unconditioned response, but it's a reaction to this neutral stimulus. What used to be a neutral stimulus, the conditioned stimulus now. Conditioned response is a learned response to a previously neutral, which is now conditioned, stimulus. Okay. So the classical conditioning process, a couple other terms you should know are extinction and spontaneous recovery. Extinction being a diminished response when the conditioned stimulus is no longer paired with the unconditioned stimulus. Right? We'll talk about this a little bit in class, but for instance, we're talking lightning and thunder still. Extinction would be that for some reason, this is probably not going to happen, but for some reason we, over the course of a couple months, lightning strikes off in the distance and you never have to hear thunder. And because of that, now you slowly are going to get less and less afraid of it. Right? The conditioned stimulus, right, is no longer paired with the unconditioned stimulus. Right? The unconditioned stimulus no longer makes us, the conditioned stimulus no longer makes us afraid. And so it slowly reverts back to a neutral stimulus because it doesn't do anything to us over time. But it does come back every now and then. We never totally lose these things, and we can relearn them, as we talked about in memorization, long-term potentiation. Right? We can relearn these things very quickly, or Ebbinghaus and the forgetting curve. We can relearn these behaviors very quickly. And it also means that at times we spontaneously recover this behavior. So even if you have turned this conditioned stimulus of lightning, which is causing anxiety, and turned that back to a neutral stimulus because of extinction, every now and then it's going to come back. Every now and then lightning is going to cause anxiety. Unfortunately, we never totally forget these things. It can become more and more spaced out, but we do hold on to those forever, and they come back quickly if the conditioned stimulus, since the neutral stimulus, is once again paired with that unconditioned stimulus of thunder. So this chart, kind of like the Ebbinghaus forgetting curve, this is like that except for behaviors. So we've got that acquisition period where you are pairing, right? That's an important word here. You're pairing the neutral stimulus, lightning, with an unconditioned stimulus, thunder. That's us learning the association. This is the association, right? Over time, the pairing of those makes it a stronger and stronger association. Okay. But then if you remove the unconditioned stimulus, say lightning only happens off in the distance, the conditioned stimulus now, lightning, which has become that over this acquisition period, it's shifted from a neutral stimulus to a conditioned stimulus. It slowly, not even slowly, pretty quickly, if it happens over and over and over again, not associated with an unconditioned stimulus, not associated with thunder, we will lose that. That becomes extinct. It no longer makes us afraid. It no longer makes us anxious. And so the more we associate a conditioned stimulus, or the less we associate a conditioned stimulus with the unconditioned stimulus, then the more we no longer are afraid of it. Okay. But you can see this pause where if nothing's happening, right, you can kind of spontaneously recover that. But then extinction happens again, right? It can come back quickly. So a couple of the terms you should know: generalization and discrimination. Generalization is that oftentimes we will associate our conditioned response not to specifically one thing, and it can be a bunch of different things, right? Famously is the little baby Albert experiments. famously also a extremely unethical study in which Watson, recall, would bring out a small baby rabbit for little baby Albert to play with, and then eventually, after a couple weeks, he would bring out the rabbit who would begin banging pipes behind the baby's head, and so the pipes were the banging of the pipes was an unconditioned stimulus, right, to make the child afraid. But eventually, the child became terrified of the white rabbit because of that neutral stimulus of the white rabbit. Now he was terrified of it, right? So he had been trained to be afraid of it. His conditioned response of fear in response to the banging of the pipes. Now he had an unconditioned response. Now he had a conditioned response to the rabbit. But he didn't just have that response to rabbit. He also did that to white mice or white rats or lighter skinned cats even. He was generalizing. He was responding to stimuli not just like the rabbits. Or to go back to the lightning, any bright lights may make you think, oh gosh, and have that response. Even if you know that wasn't lightning, your body may respond. Or kind of conditioning in classical conditioning is about automatic reflexes. Operant's different, but classical conditioning is about automatic reflexes. Another classic example of this, my dog Padfoot, and anytime I say the word outside for him, he automatically perks up. And if I can say that in whatever way I want, I don't have to say the word outside. I can say anything that sounds like it with just that general inflection, and he will hear that and have a reaction to get excited about food, right? He'll start zooming around. He'll run over to the door. He'll begin to salivate, thinking that it's time to go outside and come back in and get food. So he generalizes. Anything I say that sounds like this will make him do that, right? Discrimination is the learned ability to distinguish conditioned stimulus from other similar or irrelevant stimuli. Here's a picture of Patrick in the car with his buddy Dove. And he has not figured out yet the difference between slowing down the car to get to a stop sign or a stoplight and actually parking in the parking lot. And anytime we start getting close to somewhere, he will always start crying and start kind of jumping around in the back and get really excited about getting out. And when we pull up to a stoplight, often we'll slowly slow down and we'll look in the back mirror, and he'll stand up and start making that whimpering sound, start booping the back door come on guys, let's go play. He hasn't yet figured out the difference between actually stopping the car and just slowing down the car to a different place, right? He hasn't been able to discriminate between those, right? Learning the difference and the ability to distinguish between those. If you were talking about baby Albert, maybe if they were older, would have been able to figure out that a cat does not come with pipes banging behind your head and loud noises, but only a rabbit will do that, right? Instead of generalizing, being able to discriminate. A couple other things. Classical conditioning is biologically adaptive. The idea behind this is that it's evolutionary. From that evolutionary perspective, it helps us predict our environment and prepare for good and bad events, right? It helps us survive and to reproduce, to understand that certain behaviors are going to make us more likely to be able to mate, right? Classical conditioning is about automatic response. Arousal is an automatic response. So things that cause arousal, right? Whether that be something that you see, something that you feel, right? Whatever that is, that's an automatic response, and it's been classically conditioned in us in some way, whether by associating a neutral stimulus with a more unconditioned stimulus, we get that response of arousal. Same thing with food, avoiding danger, finding mates, for all of these things are going to be classically trained in some way, right? Classical conditioning is all about automatic reflexes. And then higher order conditioning, this is slightly different. It's where a new neutral stimuli can become a new conditioned stimulus. And so this is basically it's called second order conditioning. It's like conditioning one thing and then using that to condition another. New conditioned stimulus paired with an old conditioned stimulus. Okay. But it's never paired with an unconditioned stimulus, but it still gets the same conditioned response. So whatever our new conditioned stimulus is, right, lightning, right, we pair that with an old conditioned stimulus. We don't, however, pair it with an unconditioned stimulus of thunder, but we still get that same conditioned response. Okay. So lightning, we'll say, so as an example here, lightning would be the old conditioned stimulus, and we pair that with something new, right? If now when we see lightning, we also, right, ring a bell one time, eventually, right, if we pair those together, it's not going to be nearly as strong, but you can make the bell cause people to be anxious if you associate it with a strong enough thing like lightning. And responses are usually weaker, but this does happen to us all the time in our lives. And then finally, some limits on classical conditioning. The basic rules are that a neutral stimulus has to come before the unconditioned stimulus for it to be trained. The only time that is not the case is in this idea of taste aversion. And this found that rats exposed to radiation avoided drinking from plastic bottles in radiation lab, and they linked the plastic bottles, a conditioned stimulus, to the sickness of the unconditioned response. But that happened after, right? They threw up and they got sick after they had already drank from those plastic bottles, right? It doesn't make sense. It didn't. The sickness should have come, right, like right after it, right? It happened way after it, and that doesn't make any sense. It doesn't fall into the laws of classical conditioning. But what they found was that this is slightly different. This is a different kind of evolutionary skill that we have to be averse to foods, right? We associate a certain food with vomiting, and we're less likely to eat that again, right? We're less likely to eat it, even if it's like, way after it. And so this violates the notion that the conditioned stimulus comes after only the unconditioned stimulus in one pairing, after the unconditioned stimulus. But in this case, all you need is one time. You don't have to train anything. You can get sick, as I'm sure many of you all know. If you get sick on something, you often never want to eat it again. All it takes is one time. Okay, so that's it for classical conditioning. Sorry, a little bit lengthy, but it's a lot of terms in this topic. So go back, watch again, make sure you got those terms down, and I'll see y'all in class.